Hi, my project is the engineering and construction of a large capacity CNC router for inexpensive computerized manufacturing. The project number is EN001, and in this video I'll be providing a synopsis of the engineering and construction processes as well as a demonstration of machine capabilities. CNC stands for Computer Numerical Control. A CNC router is an automated machine that guides a spinning bit to cut and shape a workpiece. Before the prototype could be tested, it had to be constructed from the ground up. Due to the numerous safety concerns, the proper PPE was always worn whenever in the workshop setting. The construction process began with cutting dimensional steel and welding it to compose the basic frame of the CNC. The construction process was very skill-intensive, which is one of the reasons automated equipment such as this is often purchased rather than built by the user. This justifies the research completed through this project, in which the CNC router was built by hand from off-the-shelf components and custom fabricated parts. The design for this CNC router was inspired by numerous other existing designs, although the ultimate prototype took on many unique features. In its basic form, the CNC router uses 3 axes of linear motion to precisely control the location of the bit in 3-dimensional space. The X and Y axes control horizontal movement. They are both driven by NEMA 23 series stepper motors and gearboxes that pull the machine along on roller chains. This makes for precise movements. The Z-axis controls vertical movement. It uses a smaller motor and a feed screw. All this is coordinated and controlled by an onboard computer and complex electrical system. CAD, or Computer-Aided Design Software, can be used on a dedicated computer to design mechanical components, custom signage, engravings, or assemblies, such as pieces of furniture that can be machined on the CNC router quickly and efficiently. From there, the CAM, or Computer-Aided Manufacturing Software, can create a toolpath and export it as G-code, the language that the CNC runs off of. The last step is to use the CNC controller program to interpret the G-code and send pulses to the machine's motors through a parallel port. After only a handful of intuitive steps, the user is able to take a conceptual idea for a part and turn it into a physical object through the use of a CNC router. CNC routers are some of the most versatile pieces of automated machinery available to consumers and professionals alike. They are capable of performing all the functions of an entire wood shop and in a fraction of the time. During the testing phase of the project, accuracies of up to 0.005 of an inch, or 0.013 millimeters, were recorded. This level of precision is far beyond anything achievable by hand. Construction and testing took a total of 8 months. Ultimately, the project can be considered a great success. A functioning CNC router was created inexpensively, and it proved capable of all necessary functions. The high costs typically associated with automated machinery were successfully avoided through the process of manual construction of the CNC router. This technology can now become available to small businesses, schools, and innovative individuals. This availability of technology has the potential to spur innovation and creativity and allows for modern technology to be applied in the modern world.